we're going to talk about hyperbolas. Again, hyperbolas are part of conic sections. And if we take two cones, basically, and set them up vertically, tip to tip, and we cut it, I cut a slice vertically, we'll get this hyperbolic shape, or this hyperbola. With hyperbolas, we have the foci. Again, they live inside the hyperbola. And if we take the distance from one foci to a point on the hyperbola, that other foci to that same point, and if we were to subtract those distances, they would always be the same. And that's what makes a hyperbola a hyperbola. How do these things happen in everyday life? So if you take a flashlight and just lay it on a table, the light will actually hit the table in that hyperbolic shape. When a plane flies faster than the speed of sound, you can hear a sonic boom, but you can only actually hear it on that hyperbolic shape, that on the edge of that, along the earth, okay? It can be heard and felt. Cooling towers from nuclear plants, these also have that same shape, looking on the outside there of those cooling towers. All right. This shape actually helps it to do its job more effectively. So with a hyperbola, what we have is we have a transverse axis. You could call it a major axis if you'd like. And all the things happen on this axis. We have our center, we have our vertices, and we have our foci. Again, the foci live inside the hyperbola, on the inside of it. And the vertice, of course, lives on the line of the transverse. With a hyperbola, the question is, who is, and I'm not going to say line leader, I'm going to say who is positive, okay? Let's say who is positive. That's the question, who is positive? And A, the value of A, lives under the positive term. All right? We use line leader for a different one, so we're going to say positive term. If you can graph an ellipse, then you can graph a hyperbola. So first of all, let's take a look at these, and we're going to talk about being centered at 0, 0. And we can see that we're centered at 0, 0 because this, you don't see an x minus h, and you don't see a y minus k. All right, you don't see that, which means h must be 0, k must be 0. So that means my center is 0, 0. All right. Who is positive? Well, remember, with a hyperbola, we know it's a hyperbola when the x is squared and the y is squared and the terms are subtracted. When they are subtracted, that means that the first term is the positive. So, in this case, x is in front. X is positive. X, and for hyperbola, opens left and right or sideways, okay? It opens. Remember, x is a horizontal axis, so it opens left and right. What if instead y squared is the positive? Well, if y squared is the positive term, again, A lives under the positive term. All right. Well, if y is the positive term, then we're going to open up, the hyperbola will open up and down. All right. Up and down. The y-axis is a vertical axis. It makes sense that the hyperbola, if y is positive, would open up and down. Let's take a look at an example. So here, first thing we want to note is, you want to ask, is x squared? Do I have x squared? Do I have y squared? Yes, yes. And are they subtracted? Yes. Okay, that means it's a hyperbola. Next, who's in front? Who's positive? X is in front. A lives under x. Oh, okay. So that means A is 3 and B is 2. Keep in mind that if this had said x squared over 9 minus y squared over 4, I'd still get A is 3 and B is 2 because remember, 9 is equal to A squared. So you have to ask yourself, okay, what squared gives me 9? Oh, well, 3 does. Because the x squared term is in front, a tells you how wide left and right. Because it is a horizontal hyperbola, we're opening up left and right, and the vertices live a units from center. Okay, so from our center, we go a units left and a units right, and we mark our vertices. The b, because it is under the negative term, we go, for our case, b is 2. We're going to go up 2 and down 2. Now, you don't have to draw, you don't have to draw the ellipse, obviously, because it's not an ellipse, but this is how we started out. What we're going to do is, instead of drawing the ellipse, we're actually just going to draw a box. Just like that. And we're going to draw dotted lines that go corner to corner through the center. These dotted lines are called asymptotes. I know where my vertices are. They're right here. I also know that lines hug asymptotes, so that my hyperbola goes out left and right and hugs along that line. And again, because x is in front, we know that this is a left and right. Okay. One other thing is we want to talk about the equations of those asymptotes, right? These are asymptotes. Graphs hug asymptotes. They get really, really, really close, all right, but they don't touch them. When x is in front, the equation for the asymptote is y equals plus or minus b over a. Well, this is easy because a is 3 and b is 2, which means I have y equals a positive 2/3 x and y equals a negative 2/3 x. So which one's the positive and which one's the negative? Well, just remember, slope goes left to right. Remember the little ant, right? What is he doing? If I put him right here, right, Pierre the mountain climbing ant, and we put him on this line, he is going from left to right. He's going uphill, up. That's the positive guy. And if I put my friend Pierre the mountain climbing ant on this one, he is going from left to right. He's going down, 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 down. So that is the negative one. There's one more thing that I haven't actually graphed in this graph, and that's the foci. We know that the vertices live the vertices live A units from center, and the foci live C units from center. So I got to find my C value. Well, C squared is equal to A squared plus B squared. So my A is 3 squared, and my B is 2. Right? So that means that I will get 9 and 4. So C squared is 13. But I don't want C squared, I want C. So it's plus or minus the square root of 13, which is roughly 3.6. This should make sense. Let's go back and think about it for a second. Why does this actually make sense? Well, let me change colors. My foci are supposed to live inside the hyperbola. I know that this value is at 3, and I know that 3.6 is right about here. Yep, that's inside the hyperbola, the positive and the negative. So the values check out, and you always want to make sure that your values do check out. Now let's switch it up and go the other way. Again, when you get a question like this, first thing you're going to ask yourself is my x squared and is my y squared? Yes, yes. They both terms are squared. Okay, good. Are they subtracted? Yes. Okay, that means I have a hyperbola. Next, who is positive? Who is in front? Oh, y is in front. Okay, y is in front, and a lives under the positive term. So a squared is 1, which means that b squared is 16. Well, if a squared is 1, then a is 1. And if b squared is 16, then b is 4. Now, because y is in front, that means I'm going to open up and down. So a is going to tell us how far up and down to go, and b is going to tell us how far left and right to go. So again, we mark our center. It's 0, 0 because I have no h and no k. I know that I'm supposed to go, remember, opening up and down because y is in front. I'm supposed to go A units from center up. There's 1. A units from center down. There's 1. B units left and right. So 4 to the left and 4 to the right. Draw the box, draw the diagonals, and then you can draw the general shape here of your, whoopsie, hyperbola. It doesn't have to be perfect, but it's okay. Again, we're going to open up and down. Next thing, I have to figure out the equation of those asymptotes and the value of C. So for when y is in front, it's plus or minus A over B, right? When x was in front, go back and remember, when x was in front, it's B over A. And when A is in front, it's A over B. Well, I know A and I know B. So it's 4 over 1, which will give you plus or minus, wait. I put my values in here wrong. Oh, it's because it tripped me up on my colors, didn't it? My bad. Let me take these funny little boxes away. Let's try this again. I'll just do this. It's easier. Just erase it. There we go. Okay. Colors got me all tripped up. Okay. It's A over B. So we're going to have A is 1 and B is 4x. So we have a 1/4 x plus and minus 1/4 x. I was trying to make it cleaner. There we go. Okay. Now we need to find the value of C. C is going to be, again, A squared plus B squared. So C squared is going to be, I'm going to change my cursor down. Oh, goodness. I'm going to change my cursor. C squared equals A squared, which is 1 squared, plus B squared, which is 4 squared. So I'm going to get 1 squared plus 16, which will give you 17. But remember that C squared, I want the square root. So it's plus or minus the square root of 17, which is going to be roughly plus or minus 4.12. Okay. Next, you're going to have problems that maybe they won't tell you the equation, but they're just going to tell you some fun little facts, right? When in doubt, draw it out, always, right? When in doubt, draw it out, okay? You're given points, so it makes sense to plot them. So let's do that. I've got a foci at 0, 8. So there's one foci. I've got another at 0, negative 8. So there's another foci. I've got vertices at 0, 5. There's one. And 0, negative 5. And there we go. Again, let's take a look at things. We need to figure out, this is 5 units, and this is 5 units. It looks like the center is 0, 0. So it looks like H comma K, it's going to be 0, 0. Also, my vertices live A units from center, so it looks like A is 5. The foci live C units from center, and it looks like that C is 8. So I've got an A is 5, so A squared is 25. And C is 8, so C squared is going to be 64. Okay? Looking at this, just looking at this, I can already tell that this parabola is going to open up and down. Why? Because my foci live inside of it. My foci live inside of this hyperbola. And the only way that this foci lives inside anything is if I have this up and down look, okay? So let's see. In order to draw this, I have A, I have C. I need to go find B. So I've got C squared, which is 8 squared, equals 5 squared plus B squared. So I've got 64, 25 plus B squared. We're going to move that 25 over in order to get that B squared value. So we're going to have 39. And again, that's B squared, but I want B. So it's going to be plus or minus the square root of 39, which is roughly 6.2. Now let's go ahead and plot that 6.24. Remember, 6.24, it's going to be on the opposite of the hyperbola. All right, so if the hyperbola is opening up, if the hyperbola is opening up and down, that means that I want to go left and right with the values of b. Now I have everything I need in order to draw the box. So we're going to do that. And next we're going to draw our diagonals going through the center, corner to corner through the center. Now from here, I can actually finish the drawing because I can draw the curve of the hyperbola. So from the vertex, I'm going to curve out to those asymptotes. Don't touch them. And again, curve out to those asymptotes. There we go. We can see from the picture that the hyperbola opens up and down. And when a hyperbola opens up and down, we know that y squared is going to be in front. So we can actually go ahead and figure out this equation. In general terms, it's y minus k quantity squared over a squared, because that's in front, minus x minus h quantity squared over b squared equals 1. Now, I don't have a k and I don't have an h, so I can actually clean this up a bit and just say y squared and x squared. And I know the value of a is 5, so I can put 25. And I know the value of b squared. Yes, b squared is what we want, which is 39, which is what we found earlier. Let's see if we can take a look at another one. For this one, the very first thing you'll notice that is different from any of the other ones is that I do have an x minus h and I do have a y minus k. So looking at this tells me that h is 3. So we have an h and a k. H is going to be 3. Oopsie. And k is going to be 2. So 3, 2 is my center. So let's go in here and go 3 and 2 and mark it. Next, I know that a lives under the positive. A lives under the positive, and the positive term is the x term. Well, that tells me that a squared is 1, and that tells me that b squared is 3. If a squared is 1, then a is 1. And if b squared is 3, then b is the square root of 3. And for decimal values, for drawing it, 1.73. Okay, I know that the vertices live a units from center. I know that x is in front. When x is in front, when x is in front, I'm going to open left and right, which means I need to go from the center a units left and a units right. So really, really, really small 1 unit, okay? Then I need to go on the other side, I need to go up and down 1.73 to finish the box. So here we're going to go up 1.73 and we're going to go down 1.73 and we're going to make a box. So we've got our vertices. Here we go. And now we're going to draw our diagonals, corner to corner going through the center. Sorry, that diagonal's a bit off. That's all right. So I have my diagonals. I can go ahead and draw this hyperbola coming from my vertex going out to the line, but don't touching it. And we're going to do that on the same thing. The only thing left that I don't have actually is the foci, and we're going to go ahead and figure that out. Let's answer some questions over here. We've already written our answer, but that's okay. We're going to go ahead and do that. H and K, we said that was 3 and 2. The vertices live a units from center. A was 1, a squared was 1. We need to find not the b value, right? In this case, we actually need to find the c value. So c squared equals a squared, which is 1 squared, plus b squared, which is 3 squared. So I've got 1 plus 9. Oh, yeah, 1 plus 9, my bad. So c squared is 10. Oh, no, my bad. It's 1 squared plus b squared. Let me try this again. A squared is 1, b squared is 3. So I have a 1 plus 3. There we go, that's better. So c squared is 4. So c is going to be the square root, plus or minus, of 4. So that's going to give me plus or minus 2. And that should make sense. Let's go in here. The foci live c units from center. So from the center, I'm going to go 1, 2 units and 1, 2 units. And that makes sense because this foci is inside of that hyperbola. Always check your values, making sure they make sense. So we got the value of, let's see, that was 2. So c squared is going to get me 4. This hyperbola we can see opens up left and right. And we can already tell from the equation that the x squared was in front. Let's take a look at another one. Here, lots of values. Again, when in doubt, draw it out. We have a foci are located at 7, 1. So here's 7, 1. And I also have one located at negative 1, 1. So there's my other foci. It tells me the vertices are 5, 1 and 1, 1. So I have a 5, 1 and a 1, 1. And it tells me my center is at 3, 1. And there's my center. I can already tell you that this hyperbola is opening up left and right because the foci live inside the hyperbola. So let's go ahead and figure out some values. First, from the center, the vertices live a units away, and it looks like that's 2. We know that the foci live c units from center, and that looks like it is 4. So I know my c value is 4, which means c squared is 16. I know a is 2, which means that a squared is 4. They already told me the center, but I'll fill it in. I do need to find the value of b so that I can actually finish drawing this. So let's see. C squared at 16. A squared was 4. We're going to move the 4 over. So we're going to get 12 equals b squared. So b is going to be the square root, plus or minus, of 12, which is going to give you roughly 3.46. So that means that I know, take a few things away here so I can draw the hyperbola. I know from the center I need to go 3.46 up and down. So 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. From here I can draw the box. Drawing the box, remember, helps us to draw our asymptotes, and those asymptotes help us to draw the hyperbola. So corner to corner going through the center. On the other side as well, corner to corner going through the center. And now I can actually draw my graph, grab the vertice, go close to that asymptote, but don't touch it. Same thing on the other side. All right. And we can see again that this one is opening up left and right. So x squared is in front. And because x squared is in front, we can actually go ahead and come up with the equation of this hyperbola. We know it's going to be x squared over a squared, so 4, minus y squared. Oh, nope. That's not right because I have an h and a k. I've lost some room, so I'm going to clear some space. All right. So we have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. All right, my center, my h is 3, my k is 1. So I have x minus 3 squared over a squared is 4 minus a y minus k was 1, quantity squared over b squared, which was 12 if I remember correctly, equals 1. So there's our equation for that one. A lot of the times you're going to have issues where you actually have to turn an equation into a hyperbola because it's not equal to 1. We're going to do these the exact same way what we did before. This value here is obviously not 1. We need to make it 1, which means we're going to divide it by that value. Doing that gives me the 1 that I need. And when we do that to one term, we have to do it to each and every other term. 200 goes into 450 9 times, and 9 goes into 450 50 times. Cleaning it up, now it's lovely, and we can see that. If you want to write it in terms of the value of something squared and something squared, you can. This form is perfectly fine. We also have to talk about completing the squares. There's no parentheses on here, right? I can't just pull out the value of h and k and what's the value of a and b. So we have to complete the squares. And what we need to do is first take a note of the x squared and take note of the y squared. When I group the x's together, basically I want to pull something out so that this x squared term doesn't have a number in front of it. So 4, does 4 go into 24? Yes, lovely. Well, let's factor out that 4 for the x's. And over here, let's take a look at the y's. I need to get rid of that 25. Does 25 factor out of 250? Yes. Well, that's lovely. So we are going to do that too. I'm going to factor 25 out. When we factor those out, I factor out the 4 that leaves me with x squared. And then you say, oh, okay, well, 4 goes into 24 how many times? 6. And then you need to leave this spot, this blank, because that's for where we are going to complete the square. Over here, we factor out the 25. And then we say, oh, well, how many times does 25 go into 250? 10. And again, we need to leave, right? You've got to leave the space. And we're going to take this minus 489 and move it over. We have to move it over in order to finish completing the square. We're going to finish this completing the square on both terms. You remember this box, it's b sub x divided by 2 quantities squared. b sub x is basically what's the number beside x. Well, it happens to be a negative 6, so bx is negative 6. So I want to take that number, I want to divide it by 2. So I'm going to take a negative 6 and divide it by 2. Well, that's a negative 3. Now square it. I get 9. Let's do the same thing over here. What is by? What is the b value? Basically, what's the number by y? It's 10. So I need to take 10, divide it by 2. That gives me 5. Now square it. Oh, that gives me 25. Oh, okay. That means that's what's going to go in those boxes. Lovely. So that means I'm going to put a 9 here and a 25 here. Now, wait a minute. Well, that's not right. Why isn't that right? Because I haven't actually done anything on this side. You have to remember, what you do to one side, you have to do to the other side. So, over here, when we add a 9, we're not really adding a 9, we're adding a 4 times 9. And here, we're not really adding a 25, we're adding a 25 times a negative 25. So that means I have to add in a 36 and a negative 625. Be aware, okay? Things won't work out nicely if it doesn't. Now we get to look at factoring. Factors of 9 that add to give me 6. Same sign, both negative. So 3. 3 will add to give me 6, right? So x minus 3 and x minus 3. On this side, I want factors of 25 that add to give me 10. Same sign, both positive. Two things that add to give me 10, but multiply to give me 25 is a 5 and a 5. Again, they both need to be positive, so I have plus signs. When you have something written down twice, x minus 3 and x minus 3, write it down with a squared term. Same thing over here. Y plus 5, write it down with a square term, and I lost my minus sign. Right? Minus 100 on this side, and I lost it. Next, in order to finish this out for it to be a hyperbola, I have to have this side be equal to 1. And in order to do that, I have to divide both sides by that negative 100. When doing that, that will give me the positive 1 here. And we'll have our minus sign. So we'll have this standard form of the hyperbola. We can actually go ahead and figure out h and k. Looks like it's going to be a 3 and a negative 5. A lives under the x, right? Be mindful of that. A lives under the x. So a squared is 20, and b squared is 4. So the value of c squared, need to finish this one out, it's going to be 20 plus 4. C squared is going to be 24. And if you wanted the value of c, take the square root of 24. And that's going to give you roughly 4.9.